Hello everyone, I hope everybody is fine and ready to learn more about trigonometry. So this lecture discusses angles in standard position, and I start with basic definitions. So an angle in standard position is an angle which has three properties. Property number one is that the vertex of the angle is located at the origin. That's number one. Number two is that the initial arm or initial side of the angle is always on the positive x-axis. This is the one on the right side you see. And the property number three is that the terminal arm of the angle in standard position is a sort of floating arm which can be located in any of the four quadrants. Quadrant 1, 2, 3, 4 as per universal convention. So right now, the initial arm is on the positive x-axis. Same thing here, same thing here, same thing here. But the terminal arm kind of rotates, and it can be in the first quadrant or the second quadrant or the third quadrant or the fourth quadrant. So an angle in standard position can have like different shapes. It could be a small angle, maybe an acute angle, or it could be an obtuse angle where the terminal arm is located in the second quadrant, or it could be even a reflex angle where the terminal arm is in the third quadrant. And it is also possible to have the terminal arm in the fourth quadrant. So the direction, the counterclockwise direction is the positive direction. So this way is positive, and the clockwise direction is negative. So when we define angles in standard position with these three properties I mentioned, if the direction that the terminal arm rotates is counterclockwise, that angle is a positive angle. But if it's in the clockwise direction, that angle is a negative angle in standard position. So these are like basic definitions. And then wherever this terminal arm lies, it doesn't matter. It is going to make an acute angle with the x-axis. So in the first quadrant, the angle itself is equal to the acute angle that the terminal arm makes with the positive x-axis. But in the second quadrant, you see this little angle here, which is denoted by alpha. This angle, which is an acute angle between the terminal arm and the x-axis, is called a reference angle. Sometimes it's called related acute angle as well, RAA, related acute angle, or simply reference angle. And it's always a positive angle. It's always an acute angle. And I define it again. It is the angle, the acute angle, between the terminal arm and the x-axis. If the terminal arm is in the third quadrant, again, the reference angle would be that acute angle between the x-axis and the terminal arm below the x-axis. And if it's in the fourth quadrant, terminal arm, then in that case, we still have our reference angle. And I'll mention about the importance of the reference angle later on. So that's definition of reference angle, angle in standard position, positive angles, negative angles. Four definitions right there, I gave it to you. And then the smallest positive angle in standard position, the smallest positive angle, is known as the principal angle. Okay, a principal angle is the smallest positive angle in standard position. So here, for example, we have an angle in standard position which is equal to 120 degrees. The reference angle on the left is 60 degrees. It's a related acute angle. And the principal angle would be 120 degrees. Sometimes you may have a terminal arm where is in the second quadrant, but the angle has been generated by the terminal arm rotating one full revolution plus 120. So one full revolution is 360 degrees. So I'm going to have like 360, and then adding another 120. That will be what? What is 360 plus 120? It's 480 degrees, right? So the measure of the angle is 480 degrees. Okay, so it's a huge angle. But the thing is that this angle 480 degrees and our original angle 120 degrees, they both have the same terminal arm. In these cases, when we have two angles or like three angles or 10 angles which share the same terminal arm, we call these angles coterminal angles. So here right now, 120 degrees is our angle. Let me write it here in the middle. So 120 degrees is our principal angle or angle in standard position. And if I'm adding another 360, that's one full revolution, I get 480 degrees, which is the first coterminal angle I find for this angle. So a coterminal angle, a huge coterminal angle of 480 degrees, is sharing the same terminal arm with our principal angle of 120 degrees. And believe it or not, if you just have this terminal arm rotating twice or 3 times or 4 times, 2 or 3 or 4 revolutions, and then adding another 120, you are going to generate bigger and bigger angles in coterminal angles, bigger coterminal angles which share the same terminal arm. So I'm going to add 120 with 360, we got 480. I'm going to add it with another 360. So that's 2 full revolutions. I get 840 degrees. So an angle whose measure is 840 degrees in standard position happens to be a coterminal angle. So that's how you write it. You write coterminal angle with the principal angle, which was 120 degrees. Okay? Remember I said principal angle is the smallest positive angle in standard position. So among 120, 480, and 840, the smallest is 120, right? So that's the principal angle. And the thing is that this terminal arm, instead of rotating in the counterclockwise direction, positive direction, it can also rotate in the negative direction. So the terminal arm could just rotate in the negative direction. And if I use another color here, perhaps in the negative direction like this, so this angle is 180 plus another 60, that is 240. But because it's in the negative direction, so it's negative 240 degrees. So an angle in standard position whose measure is negative 240 degrees would be an angle that shares exactly the same terminal arm with our principal angle of 120 degrees. So can I say that negative 240 is another coterminal angle? Of course we can say negative 240 degrees. Okay, so we have the principal angle in the middle, that's the principal angle, and then we have a whole bunch of positive coterminal angles. So these are coterminal angles, and we may have a whole bunch of negative coterminal angles. Okay, so by adding 360 and by subtracting 360 from the principal angle, we can find infinite number of coterminal angles that they share exactly the same terminal arm. So that's mini lesson on coterminal angles. And if you want to come up with a formula, you can say on the principal angle, whatever it is, if you add it with 360 degrees or subtract 360, you are going to get the coterminal angle. Okay, so coterminal angle is equal to theta plus minus 360 degrees. And theta, I put a subscript of p so that you know that this is the principal angle. So instead of adding 360 or subtracting 360, which is in degrees, you may add 2 pi or subtract 2 pi in radian. It doesn't matter, you know. When you say hello in English or you say bonjour in French, it has the same meaning. It's just the language that is different. So here, if you say plus 360 degrees or plus 2 pi radian, it's the same idea, same concept, same everything, except that the unit of measurement would be radian instead of degrees, not the end of the world. Okay, so that was coterminal angle. So angle in standard position, reference angle, positive angles, negative angles, principal angle. That's 5 definitions right there. And the 6th one was coterminal angle. So I gave you 6 definitions of 6 different types of angles in trigonometry. Okay, so then these are special angles from the past courses. You know that pi over 4 radian is 45 degrees, pi over 6 radian is 30 degrees, pi over 3 radian is 60 degrees. So basically this is a right angle triangle whose 2 angles are 30 degrees and 60 degrees. This is another right angle triangle whose angles are 45 degrees. The 2 acute angles are equal and 45 degrees. And obviously it's an isosceles triangle. So the sides are 1 and 1. Using Pythagorean theorem, the hypotenuse automatically would be square root of 2. Here, if you consider one side to be 1 unit and the hypotenuse to be 2, then using Pythagorean theorem, 2 squared minus 1 squared, which is like 3, that would be the square of the other side. And when you take the square root, you get square root of 3. And why is this important? Well, I think in the past courses, this is not the first time you're learning trigonometry. In the past courses, you have seen this, and you have learned about SOHCAHTOA. I am not the first person who mentions the acronym SOHCAHTOA. So if you want to find sine of angle pi over 6 or sine of 30 degrees, that is the ratio of opposite over hypotenuse. So it's going to be 1 over 2. Cosine of pi over 6, as I wrote it here, or cosine of 30 degrees, is the ratio of adjacent over hypotenuse. So that would be root 3 over 2. As you clearly see here, I wrote it here. And so on and so forth. Tangent of pi over 6 would be opposite over adjacent, which is 1 over root 3. Then you can rationalize it and write it as root 3 over 3, and so on and so forth. In this one, in this triangle, sine of pi over 4 is opposite over hypotenuse using SOHCAHTOA. So opposite side is 1, hypotenuse is root 2, so 1 over root 2. And if you rationalize the denominator, you get root 2 over 2. How do you rationalize? You multiply top and bottom by square root of 2. So these, you have to know them. You have to know the exact values of special angles. What are special angles? 30 degrees, 60 degrees, 45 degrees. In French or in radian, it's going to be pi over 6, pi over 3, and pi over 4. Okay, this is the diagram of an angle in standard position. Initial arm I was talking about is always on the positive x-axis. The terminal arm lies in one of the 4 quadrants. In this case, it's the 3rd quadrant. And this shows the measure of angle theta, which is the angle in standard position. Alpha here in green is the reference angle or the related acute angle. And if you consider any point on this terminal arm, that point P has an x-coordinate, has a y-coordinate. So this vertical distance is the y, and this horizontal distance is x. And obviously in the 3rd quadrant, x is negative and y is negative 2, so both are negative. But in the 1st quadrant, x and y are both positive. Or in the 2nd quadrant, needless to say, that x is negative, y is positive. In the 4th quadrant, you tell me what's happening. X is positive to the right of y-axis, and y-coordinate of all points in the 4th quadrant are negative. Okay, so having said that, we have the definitions of sine, cos, tan, which are primary trig ratios of an angle in standard position. Sine of theta is defined as y over r. And if you remember, this is again not something new. This could be y and this could be r. So we can say this is r, this is x, and this is actually y. So it's going to be opposite over hypotenuse again. It's easy to remember, y over r. And then x over r is the definition for cos theta, and tan theta is y over x. Now the thing is that when we say r, in this right-angled triangle, the 2 legs are x and y. So the hypotenuse can be found using Pythagorean theorem. Pythagorean theorem right here at the bottom, it says x squared plus y squared equals r squared. So r, the hypotenuse, would be square root of x squared plus y squared. So that's why in the denominator, you may write square root of x squared plus y squared. So this way you find sine of theta given y and x, which are the coordinates of a point lying on the terminal arm. Cosine theta is in the same way, tangent is clear. And other than 3 primary trigonometric ratios, we have reciprocal or secondary trigonometric ratios as well. So cosecant, which is the reciprocal of sine, and then secant, the name is secant, the symbol is SEC. Secant of theta is 1 over cosine of theta, and cotangent of theta is 1 over tangent of theta. So basically all these ratios we defined earlier, we just have to flip them and change the numerator with the denominator, that is finding the reciprocal. So instead of saying, for example, y over x for tangent, now we say x over y for cotangent. Instead of saying y over r for sine theta, we're going to say r over y for cosecant of theta, which is reciprocal of sine theta. So these are like basic definitions. Now, I mentioned earlier, I said that in the 1st quadrant, x and y, everything is positive in the 1st quadrant, okay? And r is always positive. See, I wrote it here. So when we say y over r or x over r or y over x, basically all of these ratios are positive, believe it or not. So that means that in the 1st quadrant, sine is positive, cosine is positive, tangent is positive. So that's why I wrote everything top to bottom positive. From the top to bottom, sine, cos, tan. In the 2nd quadrant, because y is still positive, because in the 2nd quadrant, if you consider a point on the terminal arm, it is above the x-axis in the positive region. So it has a positive y-coordinate. So y is positive, and r is always positive. Therefore, sine will have a positive sign. So I put here plus. But cosine would be negative because x is negative in the second quadrant. Denominator r is always positive. I said it earlier right there. So cosine would be negative and tangent would be negative because positive divided by negative is negative. Similarly, in the third quadrant, we're going to have sine theta y over r, but y is negative and r is positive. So we're going to have sine negative, cosine becomes negative, tangent becomes positive because negative divided by negative is positive. In the fourth quadrant, sine is negative, cosine is positive, and tangent is negative again. So in order to remember all these plus minus signs in four quadrants, there is an acronym that is used. Sometimes they say CAST rule, C-A-S-T, CAST rule. Now, A stands for all, which means that all ratios are positive in the first quadrant. S stands for sine, and that means that sine is positive only in the second quadrant. And T stands for tangent, which means tangent is positive only in the third quadrant. And C stands for cosine, which means that cosine is positive only in the fourth quadrant. So that's something that we can remember. Like it helps you to remember the plus minus signs in four quadrants. Okay, quadrant 1, 2, 3, and 4. There's all sorts of ways you can memorize this, not necessarily CAST rule that is in the book. You can say cats are small tigers, for example. Cats are small tigers. Or you can say students adore trigonometry course. Or you can say all students take calculus. So in any way you want to memorize the CAST rule, that is okay. As long as you know the plus minus signs of these trig ratios, that would be fine. Okay, so far this much. I'll give you more examples later. Thank you.